Hey everybody!
John here.
Kendall here.
Kelly here.
And we're gonna talk about Archimedes Principle!
We're gonna start off talking about pressure. Pressure is the measure of a force on an object over the object's surface area. So a large force over a small surface area totals to a large amount of applied pressure. This can be seen in the picture below. You can't hammer a bowling pin into a wall because its base has such a large surface area. But if you try and hammer a nail into a wall with that same amount of force, because the nail has a significantly smaller surface area, the nail is going to be driven into the wall because it has more applied pressure. Pressure for objects suspended or floating in a liquid is a little trickier because if an object is submerged in a liquid, then the liquid is applying a force to all different sides of the object, as seen with the ship floating in water. But if we want to find the pressure on one surface of the object, so say the left side of the ship, it's derived from the same equation, pressure equals force over surface area. So to derive that, we start by using Newton's second law and replacing force, F, with the weight of the water, mg. So we get pressure equals mass times the acceleration due to gravity over surface area. Next, we can use the volume of the object and the density of the liquid as a substitute for the mass. So we get P equals density times volume times gravity over surface area. Now, volume is equal to surface area times height. So we can use the surface area of the object and the distance from the surface to that point. So we get P equals density times area times height times acceleration due to gravity over surface area. Finally, those surface areas cancel each other out, so we're left with pressure being equal to density times gravity times height.
Next, we are going to talk about buoyancy and the buoyant force. The buoyant force is the upward force exerted on an object submerged in a fluid. Overall, it is a force that allows objects to float. It is because of the buoyant force acting upwards that an object feels lighter in water. The equation for the buoyant force is density times volume times acceleration due to gravity. In the image, you can see the forces acting on a boat in water. Gravity is acting downwards on the boat while the buoyant force is acting upwards, allowing the boat to float in the water. Now we are going to talk about Archimedes Principle, which applies the concept of the buoyant force. Archimedes' principle states that an upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction at the center of mass of the displaced fluid. The equation is the buoyant force equals mass times the acceleration due to gravity. To derive the equation for Archimedes' principle, we will start with the equation for the buoyant force that we saw previously, which is the buoyant force equals density times volume times the acceleration due to gravity. Density is then mass divided by volume, therefore mass equals density times volume. We can then replace density times volume with mass, so we get the buoyant force equals the mass times acceleration due to gravity, which is then equal to the weight of the object. Newton's second law states that the force equals mass times acceleration. We can set up the sum of the forces for the free body diagram pictured for the y-axis. It is the buoyant force minus the weight equals ma. Since the object is not moving up or down, there is no acceleration, so the equation equals 0. Therefore, the buoyant force equals mass times the acceleration due to gravity.
Here's a diagram I found that simplifies Archimedes' principle. This first example shows if the weight of the water displaced is less than the weight of the object will sink. Otherwise, the object will flow, and the weight of the water displaced is equal to the weight of the object. In this example, we have a steel trapezoidal-looking object that has a mass of 7 pounds. However, as shown, its volume only displaces 3 pounds of water. And the steel's shape here allows it to displace more water than its weight, therefore the object floats. If we submerge this in a different fluid that was more dense than water, it may float because it would displace a greater weight of fluid. In our second example, we have an overall summary of Archimedes' principle. So when an object is submerged in a fluid, the pressure is applied from all different points of the fluid. So it's not just coming from like the top or the bottom, like from weight. And in this scenario, there's a cube submerged in water, but it hasn't totally sunk to the bottom as shown. Pressure from the left and the right of the block are the same, since they're from right here and right here are the same because there's the same distance from the edge. But the pressure going upward right here, like the pressure going this way, is greater than the pressure going downward because the bottom of the block is deeper than the top of the block. So this point is deeper than that point. So the pressure on the bottom, this pressure is greater than the pressure on the top, this pressure. The net force on the cube will be the pressure on the bottom times the surface area on the bottom minus the pressure on the top times the surface area on the bottom. So after some algebra, that was kind of confusing. After some algebra, you can get that the pressure of the top is the density times this height right here times gravity. And then the pressure times the bottom is the density times the height times this distance right here of the cube. So that this is its total distance from the top times gravity. And if we distribute these terms and simplify as shown, you can see right here. So like here we distribute the distance and the density and cancel things out. And we get the volume times density times gravity equals the force applied on the object. In simpler terms, that means force equals weight of liquid displaced. And this is Archimedes' principle.
Thanks for watching!